Hello and welcome to the Adafruit Show and Tell. I'm Liz. I'm going to be your host this evening. Before we get started, I do want to mention Adafruit is having our month of sales, and this week it's all about LEDs. So if you go to the Adafruit shop, you'll see the link to look at all the LEDs that are on sale. And of course, we have a bunch of learn guides that show off LEDs. And perhaps tonight we'll even see some LEDs. And if you have LEDs you would like to show off, you can join the stream by finding a link in our live broadcast chat over on Discord. That's at adafruit.it/Discord. And we are now going to hear from Adafruit folks, starting with Scott. Hey, Scott, how's it going?
Hi, Liz. Thank you for hosting, as always.
No problem.
I'm going to switch my camera. So I've been working on Zephyr, and I've been working on displays, and I just go to switch, and I see that my overhead is not plugged in. Let me see if I can. I was like, it's on. Oh, wait, it's not on the list.
All good.
We'll see if it manages to just, hey, look at that. Ooh, it worked. Nice.
Nice.
So what do we have here? This is the Renaissance RA8. You can see it somewhere in here. So this is Zephyr display support. So you can see the terminal output here, and if I'm able to, you'll notice you can't really see it, but Blinka here is green.
Oh, yeah.
Not the correct color. So there's work to do here. And in fact, the real secret is that it's crashed since it rendered to the display. So I've got a little more work to do. But this is a start of getting CircuitPython running. It's also really slow, which I'm not sure why. Like, it took 6 seconds to update. Which, like, display I/O is slow, but like that's even slow for display I/O. So I'm not sure what's going on. But it's a start. It's a start of supporting displays through Zephyr. So this is like a display that like they've hooked up into the Zephyr land, and then we're just detecting that like the board has a native Zephyr display and just using the Zephyr display API for that.
Very cool.
Another perk of that is that they have a simulator, which I've talked about, and they have, you can simulate to a display, and we can capture that and use it in tests as well, which is
nice.
Neat. So
Very cool.
That's one thing I'm working on.
Excellent. And are you streaming this Friday?
That's my plan, and that reminds me, I'm not streaming next Friday, and I have to ask Tim about it, and I failed. Failed to do that, so I'll ping him right now.
All good. All right. Thanks so much, Scott. Always great to see how the Zephyr progress is going.
Thanks, Liz.
All right. Have a good one. All right. And now we're going to hear from Dan Q, our resident musician. Hello. How are you?
What's up, guys? I'm good. How you doing, Liz?
Good. Good.
All right. Let me try to do a screen mirror here if I can.
Okay. Yeah.
Screen share. I've been working with the Teenage Engineering EP2350 Ting effects.
Very cool.
One moment. Let me try and do this.
Yeah, all good.
Window. Okay.
And yeah, here we go. Got add to stage.
All right. Cool.
Nice.
So yeah, it's just a little Raspberry Pi RP2350 powered microphone. So here, if I can get it going. Hello. Hey. Hi. So there's some built-in effects on it, but you can kind of go into the configure file and chain your own together. So for this week's submission for music, I tried to use all this, but I kind of couldn't produce a bass line with it so far. So working on that for next week, but
very cool.
As of now, here, if I can run through a couple things that I did with it. So I tried to start off like really basic, and I just got feedback on the mic and like held it up to my speaker to get like a really, simple feedback thing. So
very cool.
Yes, indeed. So hold on a sec. So yeah, started off with literally just this. Whoops, not that at all. One sec. Okay. All right. So let me know if it's too loud or anything.
Okay. Actually not hearing it. Oh, there we go.
There you go. So yeah, just this part. feedback.
Yeah.
Regular feedback. Anyway, sampled that into a chord. So then got this going. Big, D&B style ethereal chord.
Yeah.
And then from that, I fed it back through this, and there's a harmonizer that you can add to it.
Oh, very cool.
I did just a perfect fifth on it with reverb. Played what I just did into this so I could get like a little bit of feedback on that. And let me just get that. So yeah, like this, a little pitch shift thing. Did another pass of feedback on it so I could get something like this. Let's see if this goes. And then put all those together and got this guy. Okay.
Wow.
So that was after that.
Yeah.
And then there's a little online tool from this guy. I believe his name is Bruno Marino. And there's a little drum sequencer you can use. There's also a 4-slot sampler on here, so you can add your own samples into it. Really short, guys. It's just in mono, and they'll only play one at a time.
Oh, okay.
But yeah, I loaded it up with a kick, one little hat, another little hat, and a rim. Anyway, then I used that online tool and I sequenced. Hold on a sec. Okay. Sequenced this guy. Simple little dude. Anyway, I got that on my computer. I split those out into just, little hat, open hat, kick. And then I used the effects in this to run through the rim sample through, where is it? This thing here.
Okay.
Dub delay, classic little sound. And anyway, ran that through the microphone again so I could get a full kind of sound here. Hold on.
Sweet.
Anyway.
Sweet.
Ended in this, again, because no bass line. Have to add a bass line, double up some of the hats, but... Yep.
Very impressive.
Yeah. Thank you.
Very cool. It's great to see your process, because if folks don't know, if you've heard any music from Adafruit in the past couple of years, Dan is the one that writes them every week. So everything on SoundCloud, that's his doing. So very cool to see your process, and also using the Ting. We're talking about maybe doing some projects with that, since it's using the EP2350 and it is running MicroPython firmware. So very cool.
Yeah, once I get this all collected and saved, I want to really try to make another one where I only use this, like no Ableton effects, no like external processing or anything, and see what I can really squeeze out of it.
Nice.
So I'll come on next time once I have something like that.
Excellent. Very cool. Thanks so much for coming by, Dan.
Thanks for having me.
No problem. Have a good one. All right. Now we're going to hear from our other resident musician, John Park.
Hey, how's it going?
Hello. Good. How are you?
Good, thanks. So I'm not doing any music stuff today. I'm actually doing some game-related stuff.
Okay.
And so I've been. The story here is that I got a old 2007 era PlayStation 2 and other joystick at the thrift shop for, I think it was $7 or something like that.
Nice.
And it had PS2, PS1 output as well as USB, which is pretty cool. So I just upgraded the buttons on it, but I didn't want to mess with the brains of it because the fact that it was already designed to spit out USB and PlayStation was pretty cool. But that led me to the journey of, hey, you know what? I really like to just make my own fight stick, fighting game joystick from scratch. And so if you share the camera there, you can see what I've got so far. So this is a 3D printed case I designed that won't shut right now. I'll talk about that in a moment and why and what I'm going to do about it. And what I'm going to do, let me restart it. You'll see here, first of all, this has a cute little OLED on it. With custom graphic. I got my little Lars fight stick logo I made. And it does some neat little diagnostics and things on there. For example, all of my button presses, you can see them showing up graphically, which is just cute. But also you can see at the bottom there a little running history of what you've pressed, which is helpful if you're trying to like learn combos and things like that. I'm not much of a fight game person, but if you're trying to pull off, you know, a fireball or something like that, you can see what you hit, and you can look and see what did I miss, especially if you're in like a training mode and you have a moment. So the other thing about this that's pretty cool is that I was able to set up LED lighting on this, and you can see here we can pick between some different sort of preset options. Go to one where it's obvious. Here it's just kind of cycling around them. And it also has reactive effects when I press a button. So the thing I learned with this is that I'm going to go to all clear buttons, but you can pull apart the arcade buttons we have and use the clear housing, but the colored actuator. So that's what I'm going to do. These two on the left here are the clear ones. And since you mentioned LEDs and it's LED sale month right now, here's my LEDs. So I've got one of the questions with these kinds of arcade buttons is they don't have an integrated LED. Some of the arcade buttons that we sell do, but that's a single color LED, not neopixels. And so I wanted to use neopixels. I want the color effects. And I was like, geez, am I going to have to like wire up a bunch of little PCB, like single neopixels or sort of pull something apart? You know, I was looking at some of our neopixel strips, which are these kind of things, and they're sort of big and bulky, and how are you going to use them? And then I thought, what the heck am I thinking? These are not big and bulky. These just have like a silicone waterproofing around them. So if you pull that sheath off there, I'll just pull that back a little bit. It's actually, you kind of have to cut it off because of the friction there. But these things, and this is, of course, should be obvious to most people, this is how these started off life, was just as these little flexible PCBs that were meant to like tuck in around things and often have adhesive on the back of them. So I just wrapped these around my buttons. I get 2 LEDs per arcade button, and it's literally just sort of snaked around in a little pattern there. I'm using the black ones there. I might switch to white because I'll probably get a little more light off of those. But so that's just this like a little serpentine, snaky thing of neopixels running around.
That's cool. That's a cool idea.
I think I just killed them. They're not lighting up now.
No.
So that leads to my third thing, and this is probably something I'll be able to show tomorrow on the workshop show. I designed this case, and you can see I did some things like tried to make it not flex and add some supports, because you're pressing down on the top, and that's a pretty thin little lid there. And that stuff has worked out well. However, once I started wiring it and then started to deal with, there goes the LEDs again, started to deal with trying to close the thing, I was like, well, this was dumb. I should have put the microcontroller and all the buttons and basically everything on the lid and had an open bottom so that you can wire it, because this I kind of need to build some little wiring looms or lace it or use zip ties or something just to make it neat, because building this terrible overstuffed
I've done that exact thing before where it's I know exactly where
no reason. So so I'm gonna go ahead and I designed this parametrically, so it shouldn't actually be too much work to make some adjustments so that these two are either one thing or this still screws down so that it's a faster print. Print that separately, print the walls, and then print the bottom and screw that into place. So that's kind of where I'm at, and then I'm also doing a little bit of 2-color printing so that I can integrate some graphics or letters into there, so I know what some of those buttons are that are less used. Last thing about this is this is the EP2350 CE firmware, which is OpenStick community firmware, which is fantastic. It's got like a millisecond of latency. It's everyone loves it for real. This isn't something I try to do in Circuit Python or even in Arduino. One of the features that it has now that I've got kind of like a full button layout is you can go into some little diagnostic modes, start it up into a config mode. I'm trying to remember. I think if I do, is it going to be function and which one goes into? It's a good demo. Something goes, goes into, okay, this is function. I think it's that. No. Anyway, there's an on-screen menu that I can't remember how to launch now that lets you do a little bit of other diagnostics and change your profiles. And that's one of the things, you can set it up so that it's designed to do an X input, and then you can restart it with a different button held and do a PlayStation or a Switch or a this or that. I can never remember which one is which. If I can just learn the one thing of getting that menu to play along with me nice, then you go and pick it with like a little separate menuing system in here and say, okay, reboot, but reboot so that I can play this on the Switch. So that'll be nice. Cool. And I also have a little reset button back there. Reset button is how we go to config mode, which is not quite the one I was trying to remember how to get into. But if I go back, let me think. Is it? No idea. Tune in tomorrow.
Got a lot of features going on. Yeah.
Tune in tomorrow. Maybe I'll figure that out. Anyway, that's the Fight Stick. And most of these are Adafruit buttons, Adafruit joystick, Adafruit OLED breakout. I'm using a KB2040 on here. You can use a Pico, which would be a little bit less expensive. I decided to design a little breakout for the KB2040 because I wanted USB-C, and the Pico just doesn't have USB-C yet, and I'm so annoyed with that that I went for the KB2040. So that's what I'm up to.
Sure. Very cool. Well, looking forward to seeing even more on your workshop show tomorrow.
Come on by. Thanks, Liz.
All right. Have a good one. All right. Now we're going to hear from some community members, starting with Paul. Hey, Paul.
Hi, Liz. How are you?
Good. How are you?
I'm doing well. I just wanted to come on the show and share that the Circuit Python show is back after a break. So it came back 2 weeks ago with John Ellis and his MacroPad projects.
Very cool.
And this past Monday was Sean Carolyn, who vibe coded Pac-Man clone in Circuit Python in just one day, which I thought was crazy.
Yeah, I actually listened to that episode today.
Oh, great.
Yeah.
And then upcoming episodes include Adafruit's own John Park. I'm going to have 2 different episodes with 2 different groups of students. One group who created a medical device that's open source and uses CircuitPython as its firmware. And then a couple students from Professor John Gallagher's physical computing class at Boston College. So there's some episodes to watch out for.
Excellent. That's so cool. I love that you're still doing the CircuitPython podcast and you keep it fresh every season, new topics, new guests. So love it. Love that you're doing that.
Sunday actually marks, it'll be the 4th anniversary since the first episode dropped.
Wow.
So it's been 4 years already.
That flew by.
Yes, it has.
All right. Well, thanks so much, Paul. And definitely drop a link in the chat so folks can subscribe to the podcast so they don't miss an episode.
Will do. Thanks, Liz.
All right. Have a good one. All right. And now we're going to have Cooper play us out.
Hey, Liz. How's it going? Well,
good, how are you?
It's me and my cat here, Gigi. She
All right.
insisted on being a part of the show.
As she should.
So I have a few things. First of all, I wanted to say Dan was on earlier, right? He did the music, right?
Yeah.
The chip shortage theme is one of my favorites.
Yeah.
I don't know if you remember that one. I think it's been long gone.
I'll never forget the chip shortage.
Oh, so good, so good. Anyway, but I have something really cool to show off. So I was lucky enough to, I've been talking with Todd.Bot and stuff, and I got my hands on a Synthiota that he designed.
Nice.
And I was really excited. I developed a little helper library. So now you can install Synthiota if you're using this, just make it a little easier to use. And I just wanted to figure out what's the first project I work on, right? And so what I have here is a drone synth, which I will share these. It's going to be hard to see. It's a shame because I'm actually very proud of the UI because you can change your waveforms and it shows it and all that kind of cool stuff.
Very cool.
Anyway, but what it does, what you will be able to see is the LEDs here. And so we have we're using the synth voice library, which I developed a year or two ago, which has a drone ability. And basically what you can do is it's monophonic. There's one note at a time, basically. But you can change the number of oscillators you're using.
Okay.
So this actually demonstrates to you how many oscillators you have activated, right? And then on top of that, you can actually, there's 3 different forms of modulation, which I use the old school naming: vibrato, tremolo, and just frequency modulation. And you can actually use like for instance, that vibrato will change the color of the LED of each corresponding voice. And let's make it a little funkier here, right? So we'll get all of them in there, give you a little bit of rainbow, but it's actually useful rainbow because it shows you what's going on. And then you can also use the tremolo to control the brightness of each. So every now and then you'll see one go out, right?
Right.
And I designed the synth voice library to control each of these oscillators, but also have a little bit of like what I call detuning, both of the rate as well as the pitch and everything, just to make it sound really fat, right? Otherwise, it would just be like one really loud noise, right? So in this case, I'll bring it down because running 8 oscillators at a time it's a lot to deal with.
It's a lot, yeah.
It's a lot, you know. So I can actually press this button here because when you play a note, it'll highlight with a little yellow LED, right? Or I can press this button to latch it, and the whole thing goes red. And then whenever you change the voice, the note, it'll change to highlight the current thing. Yeah.
Very cool.
So, and it sounds crazy right now. I assume, can you hear it there?
Yeah, we're hearing it. Yeah.
Oh yeah. Okay. So like if I go up.
Yeah.
Oh yeah. And we have filter, which we're actually using these really cool touch sliders to control both the filter and the resonance.
Oh, sweet. Nice.
It's going to get a little wild in here. And then I have a number of waveforms. You can do noise, sine, everything. I have some custom waveforms to do like kind of a super saw sound.
Okay.
Anyway, I'm just playing around. I'm having a good time. And we even have effects and everything. So we're really using every little audio possibility, so we have echo, distortion, phaser, all this kind of stuff. So it's a lot of the synth work that we've been doing these past couple of years kind of combined into one.
It's nice to hear it all come together, and your UI is really intuitive to operate it, so that's really nice to see.
Oh yeah, and you can thank Todd for that to get the right controls on here to make it very easy to control. Yeah, so I'll have a demonstration video of this coming up as soon as I do a few more tweaks, but it's very close. And I know there's some hardware tweaks that have to be worked out, but I'm hoping we can get these in some more people's hands in the future.
Excellent.
Yeah.
All right.
I think that's all I got for you.
All right. Thank you so much. Great to see the work you're doing and love to see what you're working on.
Yeah, definitely.
All right. Have a good one. All right. That's going to do it for tonight's show and tell. Great projects from everybody. And tune in for the rest of the week's live streams. JP will be live tomorrow and Thursday, and then Scott's live Friday. So until then, have a great evening. Thanks, folks.